Hi everyone, it's Brooke. Welcome to the second part of my figuring out an unknown video. So first we're going to start with the carbon 13 NMR, and I hope you can remember from last time, but we figured out that our degrees of unsaturation is 4, which means there are either 4 double bonds and or rings total. And our molecular formula, which is C6H5Cl2N. So we're trying to support this data. Excuse me. So what the carbon NMR tells us is that there are 6 unique carbons, and there are only 6 carbons in our molecular formula, so they are all unique. There is no symmetry, and we know that the chemical shifts of benzene carbons are 110 to 175, and all 6 of these are within that range, so all 6 of these must be a part of our predicted benzene aromatic ring. So from here we're going to go and look at our hydrogen NMR, which tells us probably the most information. So what I did was I wrote down exactly what we knew, just like for the carbon NMR. So there are 4 different peaks, and there's an integration of 5, which also coincides with our molecular formula because it has 5 hydrogens. The 4 peaks are 1, which is a broad singlet; 2, which is expanded here, which is a doublet; 3, which is a clear doublet of doublets; and 4 right here, which is a clear doublet. So we know that for benzene, the chemical shifts for a hydrogen coming off of a benzene ring would be 6.5 to 8 ppm, and B, C, and D are all within that range, so those are most likely from our benzene ring. And we also know that a hydrogen coming off of a benzene ring connected to a nitrogen is from 3 to about 5 ppm, and we have one of those. So at the moment I'm thinking that it's going to be a benzene ring with a nitrogen and 2 hydrogens, since this is a broad peak and it has an integration of 2. So now what I went ahead and did is I compacted everything that we know from the hydrogen and carbon 13 NMR. And we know that our molecular formula is C6H5Cl2 and N. So we know that there's going to be a benzene ring, and we know that there's going to be a primary amine. And we know that this hydrogen right here has an integration of 2. So, and it's also a broad singlet, so if it was these hydrogens here, it would make sense because it would have no neighbors. So we are going to say these are the A hydrogens, and then we have 3 more hydrogens left, each with an integration of 1. And we also have 2 chlorines, and we know that there's no other carbons except for the carbons in this ring. So we'd have to figure out a way to have no symmetry, since there's no symmetry. So I would predict that there would be a chlorine next to the amine group, as well as a chlorine one away. And I would say this because looking at our hydrogens, our B hydrogen right here is just a doublet, so that means it would only see 1 neighbor, where which it could be this one right here, and because it would most likely only see this hydrogen right here, it wouldn't, doubtful that it would reach all the way across and see that guy over there. So I would say that would be B. C, I would say, would be right here, which makes sense because it's a doublet of doublets, and it could see this hydrogen as well as this hydrogen. And then D, I would say, would be over here because it's also a doublet, so it also only sees 1 hydrogen. So it would see C, unlikely B as well. So I would say that this compound right here, 2,4-dichloroaniline, is our unknown compound. So thank you for watching, and I hope you've enjoyed the video, and I hope this can help you in the future. Thanks for watching.